Hello and welcome back. My name is Corey, and this is the series where we are making Tang, a programming language from scratch. That is, we are using just our raw C++ abilities and hopefully using modern C++ where appropriate, and using tools such as Bison, Flex, and Google Test, and ICU. Haven't gotten there yet, but we will. And what else? Doxygen and Vim as our primary editor, only editor actually I should say right now. But anyway, yeah, we're doing that. We're writing a programming language from scratch. This is episode 25. Wow, I can't believe we're this far already. But episode 25. And what we're going to be doing today is we're going to be taking a step back. We've been coding, doing a lot of work, and now we're going to kind of do a little bit of, I want to say cleanup, housekeeping. First of all, we want to see if we've got memory leaks, which I think we do. I remember checking this a long time ago, and then I never got back to it. So this is unscripted. We're going to see what happens live. As always, I say this is 100% live coding. Nothing up my sleeves, right? I'm just in front of you bare with all of this, and you see all of my mistakes. So what we're going to do is of course, if I say get status, there's nothing in there, and get log. The very last commit was the end of episode 24. That's on GitHub right now. So we're just going to jump in. Yeah. And what I'm going to do is I'm going to say make... Do I want to do this full screen? Well, what I'm arguing with myself at this exact moment is I know that valgrind uses... Oh, wait. Could I do it if I... No, it's just fine on full screen. Make clean, make test. So this is a fresh compile. And of course we know it's going to compile. It's going to run. All the tests are going to pass because that's where we were at the end of the last thing. And I know it says 21 tests and it's taking a millisecond to run, but there's actually some of these have 10 and one of them has almost 20 programs that are all being compiled and running in that time. So I think we're probably doing pretty good on time, I hope. So what am I doing now? We want to run valgrind. Now, if you haven't installed it, I don't think I've got that in the install instructions, so it should be something like sudo apt install valgrind. Yeah, I think it would just be that, and you enter your password. It's all asterisks, right? And I mean, I already had it installed, but anyway, okay, so we're going to run valgrind. First of all, what are we going to run it on? I'm going to run it on test because we've got 3 tests. Our garbage collected test, and that just tests the behavior of the garbage collected. Garbage collected, what's the word I'm trying to say? The garbage collected class, yes. And we've got one for singleton object pool if you can't see where I'm pointing. There we go. Garbage collected test, we've got that one, and it uses the singleton object pool. And then we've got a test for just the singleton object pool to make sure that it's working correctly. But I'm going to run it on the main test because it uses all of it, and it uses it in a bunch of different ways. That's where we're going to do it. Okay, so the path to that is running normal test. It's going to be that, and I'm not even going to do the gtest brief. So if I type in valgrind, it yeah, no. It says I didn't give a program. You can, of course, grind and dash dash help and find out all of this stuff. But we're just going to valgrind and the name of our test. See what happens. Okay, so we ran all the tests. And, okay, I mean, they're passing, of course. And it says we have definitely lost a little over a kilobyte in 29 blocks. That's not good. And 29 blocks, that's weird. We don't have 29 tests, so it's not. We've got 21 tests, so there's more than one block being lost per test, so it's not related to tests. Yeah, okay, so it gives an option. It says we can rerun it with dash dash leak check full to see the details. So, dash dash leak check is equal to full. All right. So what's this give us? So at the bottom, we still have the summary, 29 blocks. And so, 29 errors, yeah. Lost record, but why 34? Oh, there's this number 5. That 29 plus 5 is 34. So it says that there's 5 still reachable. What does that mean? I'm not sure yet, but okay. But definitely lost 29. So this one is... this is the topmost line is, and I'm not an expert on valgrind or GDB or anything like that, but well, we'll see how it goes. But this topmost line is where the new happened, and of course it happened somewhere in this library. And we can go through the new allocator.h, allocator.h. I don't know where any of this is. It looks like it's all part of the C++ standard lib. This one is indeed, so it's part of a string, basic string, basic string, basic string, basic string error. That's interesting. The error class doesn't have any memory, any pointers that it's tracking. We can pull up our handy dandy little documentation. Classes, let's look at the error class. Yeah, it's got a location and a string, standard string, but these aren't pointers. Yeah, they're not pointers. They're just... okay. Where does that come from? Oh, well, of course it's by computed expression error. And a garbage collected is making that computed expression error. And that comes from, a test body of 471. You know what? Let's open that and just have to find the right window. So, where do we say that's, this is in our test? Okay. Test.cpp and 471, and that's that line right there. So that's, I don't know if, well, it would have to be, wait. I was going to say, is it the, we know this test is passing, so that means get result is returning an error, and then it's creating an error here. Which one is it? Well, the error that it's creating here is going to pass out of scope. And Yeah, it's going to pass out of scope, so it's going to clean up after itself. So it's got to be the error that's being returned. All right. And this is the last. This is lost record 3434. So that's the last one. And I'm kind of curious. Okay. It's the last error. What's the previous one? There. If we go up, so lost record 33, it is also an error, and it is from test 471, and that is, oh, wait. Okay. The one above that is an error. Oh, sorry. So there's that. This one is 469, which is that one. Okay. And above that, it is another error from 469. Don't know why it's in there twice. Well, there's two errors. Maybe that's why. Go up. This is, so this is 30 of 34. This is another error. And this is 424. So if we go to back to 424. Okay, so it's only happening with the errors. I bet if we go through all of these, they're all going to say error. I'm just going to scroll up to one of them, like this one at 23. It's an error. Okay. Why? Why errors? I mean, I'll tell you what I'm thinking. The errors are the only ones with strings. That shouldn't matter. No, wait. Wait. Of all of our types, these are computed expressions, right? So if we look at our class list, for example, we've got a computed expression that's just a bare one, a Boolean, and it stores a Boolean, an error stores an error, which is what we're looking at, float stores a float, integer stores an integer, and a null stores nothing. I would bet you a Boolean doesn't have any. It's just a basic type. It's not storing a class. A float is a basic type, not storing a class. Integer, same thing. Null, not storing anything. Computed expression is not storing anything. The error is the only one that's having to track an error. And this is a computed expression error. But when it gets deleted, it cleans up after itself. It's not storing the error as a pointer. I mean, we can look, yeah, computed expression error. It's, well, it's not going to show us private stuff in here. So we would have to open this over here. Let's edit the include for computed expression error. And yeah, it's just an error. It's not a pointer. I'm going to scroll back down to the bottom. There we go. The last one, just because cleanest, just to look at that. Error. Where is it being created? Oh! It's part of the garbage collected thing, right? That's this right here. Computed expression error is created by the garbage collected make. So it's being created there. Why doesn't it go away? Why doesn't it get cleaned up? Let's look at the garbage collected. We've got our operator, plus minus times. And that's it. These are only operators. Oh, because the make is templated, which means it's only in the header. Include garbage collected. And this is our make. Garbage collected make. We get the singleton instance. We create it with new. Okay, so that's where it's being created with the new. And we've got a recycle where we call the recycle. What happens in the destructor for the garbage collected? Here it is. In our destructor, we say if the count, we decrement the count, and if it's equal to 0, we recycle. We call recycle, which recycle was created above. It's a lambda. And we delete count. So we're cleaning up after count. And besides, count is not giving us the error. It's the computed expression error. What's that recycle got in it? It's right here. The singleton object pool, what does it do when I call recycle? It's templated, so it's going to be in the include. When I call recycle, what does it do? Lock? Okay, yeah, it's gonna lock it. Make sure it's got place to store it. That's fine. And obj is what we're, is what we're passing in. And that's the only place. It just puts it. Do you see it? Not here. It's what's missing. And that is in garbage collected, we never call the destructor. When we're recycling it, we never call the destructor. Now, why is it not? Well, okay, computed expression, integer, bool, null, float. Those all have basic data types. They don't need a destructor called on them. But if we never call the destructor, then the destructor for that error never gets called. that's why it's showing up here. It's saying error created a string and blah, 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 and that created a new. So error was created as part of a computed expression, but we never call the destructor of the computed expression, which therefore never calls the destructor of error, which therefore never calls the destructor of that string. That's the problem. It's templated. How do we call the destructor? I told you I don't work with templates that often. I wonder... First of all, what is temp? I don't like auto in these cases. It's an object pool of type T. So T's our type. We're getting an... Excuse me. Sorry. We're getting an instance. In case you're wondering, it is a little past midnight for me. That's when I do my best work. We hope. It's getting one, and then I'm using that. So temp is definitely a pointer because that's what you have to use for it. So it's a pointer of type T. Here, we can test this. T star. That should be right. And if I make test, that should compile. Okay, compiles and tests run, nothing's died. That's always a good thing. All right, so if temp is this pointer to T and we're passing it in through the closure here, and we're recycling it there, we need to call the destructor. How do we call the destructor? Normally you'd say, because you don't call destructors explicitly. It's normally done for you automatically, but since we're managing the memory by hand, we don't have that. So this is a pointer, so we need to use an arrow, and normally it would be tilde and the class name. We don't have the class name, but we do have a T. Will that work? Let's try that. Everything passed. That's always a good thing. It didn't give us a seg fault. Let's run valgrind. Look at that. Right there. Definitely lost. Before it was 1K and now nothing. Oh yeah. That's always good. Okay. But why is there still stuff in use at exit? 40 bytes in 5 blocks. So there were 4,070 allocations and only 4,065 frees. Feels like a lot of allocations. Well, we're in test and we're running multiple programs. Maybe. I need these two options. So let's do leak check equals full, show leak kinds equal all. Okay. So these are lost records 5 of 5, and these are the still reachables. What are they? Where do I see it? It's Tang, object pool. So it's a malloc that's in the library. And where is that being called from? From the make of a computed expression. That's, what is that? Oh, it's in garbage collected, HPP. Let's go there. Oh wait, aren't I already in garbage collected HPP? I am. And I'm in the make, so line 67, wait. No, singleton object pool, not garbage collected, sorry. I was reading this line here, garbage collected, but it's this one I need to be looking at. In the singleton object pool, which is singleton object pool.hpp. So singleton object pool.hpp, and oh wait, where do we need to go? Line 67. Okay. That's this one right here. If you it's a realloc. So the only thing that's is this arrow allocations. It's being put into new allocation, and then we're making sure that it's, so if it failed, it would free it. Oh no, it would free something that it allocated earlier. And down here, new allocation gets applied to allocations. So do I clean up allocations? Where's the destructor? I need to look for a tilde. Oops, I don't need to be in visual at all. Okay. The tilde. There we go. Okay, destructor. I free allocation sub I and I free recycled. I never free allocations itself. I don't want to just free it. Whatever. I want to only free it if it had something in it, right? So when would it have had? When this is created, what are those initialized to? The constructor, there we go. Allocations is a null pointer, recycled is a null. We should, I'm surprised we didn't have a problem. So this makes sense, by the way, to call current allocations, but it should be if this allocations. If that exists, then do that. And then free allocations. And then we should wrap this if this recycled yeah. Don't free memory unless it was okay. That should work. Is it going to compile? Make clean. Make test. You know, normally I just run make test. I could do something like J8 and it's going to do a lot of them at the same time. It just interweaves. Allocations. Allocations is what it should be. Allocations. There we go. Let's do that again. And you'll see it kind of, it goes faster, but the output is sometimes interleaved. In the end, okay, it worked. Let's run valgrind on it. Ooh, hey. Looky here. And you said exit 0, and there were 470 Alex and 470 freeze. No leaks are possible. Yes. Detected and suppressed errors run with -S. Let's do that just to see if there was anything. So -S. Nope, there wasn't. Hey, we fixed some memory leaks. Let's see, so get status, get diff, okay, get commit -am, fix memory leaks. All right, now the other thing I wanted to do is we had looked, and AST node has this make copy, and computed expression also has where is it? It also has a make copy, and the question is do we still need it? I'm going to say that we definitely need it for the computed expression because we're dealing with raw pointers. Are we? Are we though? Yes, we're dealing with raw pointers. Even though it's garbage collected, there's going to be times where we need to, instead of, we don't want a copy of the pointer, we want a fresh. Let's just look at the make copy of something. Source, computed expression, Boolean. And what's its make copy going to do? Now, we don't have any place in our code yet that needs to make a copy. But why would we need to make a copy of a computed expression, especially when we've got the shared pointer thing? Or not shared pointers. We've got a garbage collected class that's faster than shared pointers. And now it doesn't have memory leaks. When we go to doing functions and we need to pass an argument in. Yeah, that's the case. If we have a computed expression, a is equal to 3, a will have the garbage collected computed expression of 3. Now we need to pass that to a function as an argument, and then maybe that function will do something with it and change its value. You don't want it changing the outside one. So in that case, you will have called a make copy. The problem is this is dealing with raw pointers, and we are no longer using raw pointers. So the computed expression make copy needs to become a garbage collected value. Yes, I'm arguing with myself mentally, right, internally, and I think I'm right. So I've won this argument. So let's do some stuff. I want to switch my screens around, my windows around, just because. Well, I put this over here because we were doing the test. So then we're going to edit all of our includes first. Include computed expression everything, and then source computed expression everything. Okay. Now over here, just make, there we go. So it's going to be running in the background. It's going to start complaining. I'm okay with that. So computed expression.h. Let's do that one first. Computed expression.hpp. Oh, it's buffer 4. It already has garbage collected included, and for the make copy, one under the limit of 80. The limit of 80 is one that that's a personal thing. So garbage collected, make copy, it's going to start complaining that garbage collected.cpp is what I need now. Oops, no. Garbage collected.cpp. Not garbage collected, a computed expression.cpp. That's buffer 8. So buffer 4 and buffer 8. This should be garbage collected, and it's not going to return a new computed expression. It's going to return a garbage collected make computed expression that I don't pass anything to. And it's complaining about Garbage collected, make copy. Okay. I didn't save it, evidently. And now it's going to start complaining about these like computer expression error, that it says it's an override, but it's not. That's why you add the word override, so that as you refactor, you get all the stuff in there. Okay. BD and I already changed that one. Okay, now B0 or B1. Yeah, B1. Okay. So what am I going to do? I'm going to make copy. This should be garbage collected. Okay, it's going to be the same for every single. So buffer next. It's make copy. Buffer next. It's make copy. It's the next one. This one's make copy. Okay. And this one's make copy should be that. Okay, so that was all the HPP ones, and now we've got to start. Okay, so the Boolean is no longer this. It's garbage collected, and we're going to return a garbage collected make computed expression Boolean. Okay, it's happy with that now. Next is the, well, it's an error. Garbage collected. That should work. Okay. Sorry. Garbage collected. Integer, this one. And we're back to the beginning. Okay. Hey, everything compiled? Everything's running. That's good. All right, now what are the changes? Oh wow, a lot of changes. Git diff. Just seeing what changes I made. Nothing unintended. Good. So git commit dash am, and this is going to be that should be fine. Okay. And last but not least, so garbage collected. I'm going to go into my includes and get, because I'll go ahead and tell you what I'm thinking. I mentioned this in a previous one. It was kind of in the back of my mind. This AST node, it also has where's your there. It also has a make copy. You know, so let's just open this, the AST node, before I get too far into this. Vim AST node.hpp. All right, so does this even need to be protected anymore, or can it be private? You know, we're about to find out. Ah, okay. See? Fixing my errors. There we go. What are my... Okay, so protected, I've got a location, but that's not memory managed. And our make shared uses a shared pointer. And you know what? We use shared pointers for everything, which means, because before we were using brawl pointers, and that means that's why we needed the make copy. But in this case, I don't think we need... ASTs are only to be used internally by the program itself. Do we ever need to make a copy of an AST? Or can we just copy the pointer? If we make a copy of a program, do we need to copy the AST? It could, if it's the same, we're not recompiling it, we don't need this anymore. Okay, before I go on a deleting spree, I just want to make sure. So git grep-n, and what am I looking for? Make copy. I want to know every place it's used. So in the includes, it's just using the declarations. That makes sense. And we do need it in the computed expression. But let's go into the source and run that same search. Let's see. Just highlighting. AST node, that's the definition. Node assigned, that's the definition. That's the next line. So that's inside the definition. This is also the function definition, that's the next line of it. Function definition, next line. No, wait. Function definition, function definition, function definition, next line. So it's inside the function. Same thing here. Function definition, function definition, function definition. All of that. And that's the next line. We don't need it. We're going to rip it out. So, I'm going to go back and we're going to say vim star dot, source AST node. Did I get them all? I did. We're going to start with astnode.hpp. That's 7. Buffer 7. There we go. And the make... Wait, where is this? Oh, make copy. And we're now going to go into astnode.cpp, which is 17. We got a lot of files to edit. For the make copy, okay. And now, again, because we marked them override, it's going to say, no, if we didn't have the word override, all of this would have compiled just fine. It would have said, oh, you're adding a function that wasn't in the parent. That's fine. But since we said override, that means it's telling it, no, I'm intentionally trying to override something. And since I deleted the one in the parent one, yeah, it's not going to compile again until I get it all cleaned up. And that's what I want. So that's why we use it. So, buffer 1. Make copy, gone. Make copy, gone. Make copy is gone. This is astnode boolean. Oh, there's the make copy. It's gone. The cast. The float. And, oh, already did this one. Where's make copy? Gone. 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 I realized I could search for it and it will take me directly to the line. The unary. This one, I just don't know how big it is. There we go. D3. Oh, that's the base one. Okay, keep going. No, this has 2 lines there. I only want 1. There we go. this is hard for my brain to wrap around sometimes, that all I'm having to do is these few keystrokes and it's getting everything and I'm not messing up. So like just to move to the next one. Okay, so it's gone. Oh, there was something in program. That's why we use version control if we have to go back. You know, let's go there. It's in program.cpp. So source program.cpp, and where is it? Line 32. This arrow AST. Wait a second. AST. Else. The include for program. AST is... Oh, it's a shared pointer. It's managed. I don't need to use the make copy. Yeah. It could just be that. In line 54. This one could also be seems like it's behaving. It's almost... No, I didn't mean to do that. Wrong window. It's almost too good to be true. Make clear. Make clean. I know, I'm, you know, doing this all from scratch. Or, I mean, it's because I just want to make sure that it all does work. I didn't, because remember, I've got a dependency somewhere that it's not in my make file. I just have to find it. But they all pass. I think that is a victory. So over here, there's something on the left-hand side I want to keep on this screen. So I'll just do this here. Get status, all of those, get diff. I'm just going to eyeball everything. Remove AST node, make copy, etc. Pointers. I don't like because. Is no longer needed since changing to shared pointers. Sure. Okay. 63 deletions. Hey, we are losing lines. That's actually, I like that. I know I often look at the line count, but yeah, we don't need everything. The other thing I wanted to look at is when I was looking at, no, that is the wrong thing. Program.hpp 24, buffer 24. when I'm looking at this, we had to do the rule of 5 because we were using a pointer to AST. And now all that we've got left is a pointer to an error message. And we could just use result for that. I've committed everything. So now I'm wondering if I just do that. And now, can I get rid of my destructor, all of my rule of 5 stuff? That's all the way down to destructor, copy constructor, copy assignment, move constructor, move assignment. What am I missing? Or did I just miscount? Yeah, destructor, copy constructor, copy assignment, move constructor, move assignment. Yeah. So maybe this is going to be complaining because I need to now remove them from program.cpp, which is in the previous buffer. Okay, so that's my constructor. Still need that. I don't need this because I no longer have an error. No longer need that one. No longer need that one. That's 3 down. Greater equal. Oh, yeah. D24. Those are all gone now. Yeah. Okay. Now what are my errors? Does not have a field name error. So where is that? Oh, in my constructor. You need to... Error no longer exists. Yeah. What else? Line 107. In program, not where I am. Oh, line 16. Ha. Let's see. Line 26. Ooh. So this is going to change how my parser works. That's why. That's this error. It was a pointer, so I could do this. I could say error E ampersand E. You know, why am I even cutting it short? It parses, and then this error is, well, that should be a pointer to a garbage collected value, which if error dot message, can I do that? Or should it be length? Because it's going to be a string. So if I need to know how does the parser work? I think I'm doing this wrong. I think this needs to be an error pointer called error, and I pass in error, and this is going to be null pointer. And if error result is equal to okay, so the way that this works is that error is just a pointer. Parser is going to, if it finds an error, it creates that message, which then would change. Error would no longer be a null pointer. And so now say, well, if there's an actual error there, turn that into a computed expression, delete the error, and it's stored in result. Yeah. So now that means when we compile something, sorry, my brain stopped working, but because I was saying when we compile something, if it has a syntax error, now result will contain that error, which should have a location with it, which means we can use that in our test to say, you know, we're testing for what compiles and what doesn't. Yes, I think I like that idea. Okay, we're going to do that. Having said all of that, I think we're probably at the limit of what we can do today. Yeah, we're a little over an hour. It is almost 1 a.m. for me. And so let's do this. Let's make clean, make test. And while that's doing that, we'll come over here. Just to... We removed stuff. Always happy to do that. As long as we have better functionality. m remove pointer to error in program and rule of 5. Okay. In program. Everything is passed. That means I can do this. Commit now. If I... Yeah. So if I do... not get, but make docs-pdf, it will do its thing. And then get status, I think it's just going to show modified. Yeah, it only shows modified, and I think that things will be deleted. I could be wrong. So rm-rf docs, and now I'm going to rerun the make docs. Get status. Is there anything here that says deleted? Modified, modified, modified. Yeah, there's some stuff that's deleted. So if I say git add docs, yeah, it added the deleted. I don't think that git add used to add deleted files. I think you had to do that manually or with an update option or something. But okay, before I commit it, let's do a quick sanity check. We've got our main page, and now in our classes, if we look into AST node, for example, we no longer have the make a copy, but if we look in computed expression, we still have make copy. It should be there, but it's garbage collected, and it's linked appropriately. And then the program class no longer has... Yeah, we can just call get result, and it will... Yeah, okay. It's working. It's how it should be. Let's wrap this up. Git commit -am, update documentation for episode, I don't remember. It's 1 a.m. How am I supposed to remember that? Episode 25. Okay. For episode 25. Episode 25 is pushed, and get tag. (025-m) episode.025. It's there. We look at our lines of code. We've got about 3,000 lines of code, and 1,000 lines of comments. So that puts us around 4,000 lines for the code base, not counting our blank lines. Yeah, it's a respectable project. Not bad after only 25 episodes. And again, so that was 313. If I get check out episode.024, make clock, we'll see that we have less documentation because we removed some functions. but definitely less lines of code now. So, okay. We'll switch back. And we no longer have memory leaks. Always a good thing. And in fact, if we want to verify that, valgrind, what is it? Build apps test. There we go. So even though we got rid of the rule of 5, because we no longer needed it, because now everything's managed, and we got rid of the AST's make copy, because now it's all using shared pointers, and so therefore we don't need it. And we're using garbage collected for the computed expressions, so that's all working. We still have... we can run it with -s, just to make sure. I'm going to say, -s. And no leaks are possible. It's clean. It's working. Hey. This is all great. And so it's up there on GitHub. I'll be uploading this. And as always, you know what? I hope you're enjoying the ride. And I hope it's been useful to you. And yeah, as always, have a great day.